As a professional material artist, you need to keep learning, and something many of us don't know about is pixel processor. Last week I showed you the basics, but in order to learn this properly, we need to put it to test in a practical example, and today we will jump in Substance Designer to generate our own blur nodes. We will create two of them, one known as a box blur and another one known as a Gaussian blur. So let's get started. In order to create these blurs, I had to learn something that messed up with my mind the first time I tried, and that is the kernel convolution. Don't worry, I got you covered on this one, and I will explain it really easy. The convolution kernel is a filter matrix that we use in order to extract local filters from an image. To make it easier for you, we are going to see a process that allows us to edit each pixel of our image to generate an effect. So how does this work? Let me show you with some drawings. So we're here in PRF, and I want to blur an image. So I'm gonna draw my image, yes, in here, yeah. And in order to blur this image, we need to apply what we call a kernel, yes. After this kernel, we are gonna be able to achieve, yes, our blur. Now, how does the kernel work? In order to know how this works, we need to understand something. Every image that we see has a matrix. A matrix is a grid. This grid is gonna be bigger or smaller depending on the resolution of the image, and each of these squares inside of our grid are gonna have specific values. Those values are the values of our pixels, yeah. So as you can see here, I'm just trying to draw it a little bit bigger. So in here, yeah, we have the grid of our image. So every single cell of this grid is a pixel, and they hold for a value. Yes, every pixel has a value. So I'm gonna try write a value for each of these squares here. Yeah, and I'm gonna do it in a square, and you're gonna realize why later. So I'm gonna just go with some numbers. Yeah, don't mind my writing. And let's do 2, 1, 6, 13, 2 again. Let's go 11 here. Let's go 3, 15, 20, 9 again, and 10 again. Yeah, so these are all our pixels, and each of them, yeah, has its own value, as I said. Now, what is going to do our kernel? So our kernel has also a grid. It has also a matrix. Yeah, and this matrix needs to be smaller than the matrix of our image. That means that this one, yes, should be bigger than this one. Yeah, always. It always has to be like that. I don't know the technical reason for that, but that's how I learned it. So in order to make this happen, I need to draw my kernel, and I'm gonna do a 3x3 kernel. So I'm gonna draw 4 lines first, yeah, kind of like this. They're not equally distributed, as you can see. I'm not really good at this part, so I'm just gonna do a 4x4. There we go. I'm just gonna close this here. Yeah, it doesn't matter if they are not the same size. It's just my problem drawing. So this kernel grid, or this matrix, has as well cells, just like our image matrix, and each of these cells are gonna have a weight. Yes, instead of having a value, they're gonna have a weight, and in this case, the weight of our cells is gonna be 1. Why are we choosing to have a value of 1? And yes, this is something we are choosing. So I'm gonna change color once again, and I'm gonna go down here. So we are going to work with a box blur. Yes, so a box blur takes every single pixel, yes, as important. So we take each pixel of our image as important. That's why we are having a value of 1 in each of them, because all of these pixels are weight the same for us, are as important for us as for everyone else. So we are setting a value of 1. So what do we do with this kernel? As I said before, our kernel helps us process this image into converting them into a blur, but in order to do that, we need to make a process where we calculate each single pixel. Now, if we pull this grid on top of this, we wouldn't know what to do because we don't know what pixel we want to focus on. So the center of our grid, yeah, this part here, is gonna be the pixel that we want to change. Yeah, remember that we are choosing a specific pixel, and we are changing that pixel, and we need to do this over and over again in all our image. So this grid here is gonna be the one we are going to change. The reason why I'm drawing it here is because the kernel, yes, and looks like I draw all together, so now I can't split them. So the kernel is this grid that we're gonna put on top of our grid. Yes, that means that we're gonna center, yes, our grid to one of the pixels in our image. Yeah, we're gonna run some calculations that I'm gonna tell you which ones now, and after we finish that, we're gonna go to the next pixel. So we're gonna do the same for each pixel. So we center this grid, yes, we center this grid into one of our pixels. Yeah, we make a calculation based on both grids and then we move to the next pixel. So how do we do these calculations? In order to calculate this, what you need to do is first you need to align your grid with the one in here. So I'm just gonna draw it here in blue so you can see it. Yeah, so it's visually visible. Yeah, so this is the grid that I'm holding on top of the matrix of my image. Yeah, and the weight of each cell is 1, and the values I'm gonna be affecting are this one. Yeah. So what I need to do now, I need to multiply. Yes, I need to multiply the values of each cell in my image by each weight I have in my kernel. This, it's gonna give you a number. Yes, so give me 2 seconds because I'm gonna need a calculator for this. But pretty much as we are using a 1 by 1, we need to add all of these values together. So if we add all of these values together, I mean if we multiply all of these values together and then we add them, yes, it's gonna give you a value of 87. Now, what do we do with this number? If we just use this value in our image, what's gonna happen is that our image is gonna look too bright or too dark. So in order to maintain the blur and also to get the blur we want, we need to divide this by the values that holds our kernel. Yes, that means that we are going to add each of these cells values. Yes, here, that in this case, as it is a 3 by 3 and all of them are 1, we have a 9, and we're gonna take it here and divide it by this, by the result of these two. Yeah, of all of these values add together. Yes, and this is gonna give us a number. Yes, this number is the pixel that we're gonna have here. Yeah, so again, let me do the math. So the result is 9.6. Now we need to round this up. So we're gonna do it on 10. And what's gonna happen with this new value? This new value is gonna replace the value that we have in the center of our grid. So now the pixel we have here is no longer a value of 2, it's a value of 10. And now that we have finished this, what we need to do is we need to move it forward. Yes, we need to go to the next node. So we're gonna do exactly the same with this node here, the one that we have on 13. And for this one, I'm gonna pick a different color just to mark it up so you can actually see it. Yes, this is the new pixel that we're going to work on, and of course all our grid is going to move one row to the right. That means that now we're going to go over this area here, yes, and we are going to ignore this area here, and we're going to work with only this here. That the color is not really visible showing, so I'm just going to draw again here. Yeah, so we're gonna work with this new area, focusing on this pixel, and we're gonna ignore this area. And you have to do this with each pixel. Now, this is the theory, but how do we tell this to Substance Designer? So the first thing we need to do is we need to calculate directions. And yes, we need to do this. Why do we have to do this? We need to tell our software that we want to read this pixel, and then we want to calculate, make all of these calculations on different directions. We are talking about directions because we need to do it in this pixel, on this one, on this one, this one, this one, this one, and this one. That means we have to go in all directions. We have to go right, left, top, down, bottom left, top, right, bottom right, and bottom left. Yes, and in order to do that, we need to calculate vectors. So let me show you how to do it inside Substance Designer for Pixel Processor. So we're here in Substance Designer. We just got inside the Pixel Processor. In case you haven't seen the last video, I do recommend that you go and watch it to learn the basics. But remember that we always create a node by looking for it in our Substance graph. Then we input something, and that's how we start. Yeah. So now I'm here. I already did this for you, and you can see how the blur is working. Now, in order to see this better, I set the resolution of my graph to 1512. If I set this to 4K, what's gonna happen is that the resolution is gonna be way too high. I'm not gonna be able to see the pixels. So set your graph to 1512 so you can actually see the result of your pixels. You can see here how it looks first on my Clouds 1 and how it looks when I apply the blur. So now let's get into the graph and take a look at this, because there's a lot we're gonna be working on and we have to explain. So in here, yes, we are turning our information on our image into vectors. And this is the most important part. So what we're doing here is we're getting a float2. A float2, remember, is our pixel value in this case, because we're going for a size. So the get float, or the float2, yes, is a data type that holds two types of information. It holds an X and Y value, and these type of informations are decimals, yes? So it is a number that has a comma. Now, a float value, and this was my mistake that I just mentioned, is not a vector. It's just a value. It's data, yes? We need to turn this into information. So how do we turn this into information to be a vector? What we do is, with a get float, we look for the $sign size function. Yes, that is basically something, is a function that is inside Substance Designer included. And what we are going to do with this is we're going to look for the size and location of each pixel in our screen. So now with this node, we are assigning a size to all of these pixels you see here. And in order to give them a vector, we need to use a swizzle float 1. So we are taking the information. Yes, this looks kind of like a compound mask, yes, as in Unreal Engine, and we are assigning this to an X and this to a Y. So we are creating vectors. Then we are dividing this by 1, yes, to maintain a number, and we are getting all this information into a vector float 2. These allow us to transform the information from float values to vectors. And of course, we're using a float 2 because we are using X and Y. And here comes the hard part that I need to get back to draw, yeah? So give me 2 seconds, I'll be right back. We're going to be in PureRef. In order to calculate all of these directions, we need to understand something quite specific of Substance Designer. Every image in the 2D space has coordinates. Yeah, so let's say this is our image. Yeah, this is the 2D viewport of Substance Designer, and we are working with an image. This image, yes, has two types of directions because we're dealing with 2D information. We have this direction and we also have this direction. This is the x-axis and this is the y-axis. And usually, if you have seen this in math, like these kind of graphs where you have this, or maybe you have something more like this or like this, whatever kind of function you want to have, you have positive values of y on the top and positive values of x on the right. And then you can take these to negative values, yes, in both sides. In Substance Designer, the y value is inverted. Yes, this is let's call this the traditional. Let's just go leave it as traditional. In Substance Designer, this is the opposite. The y value on the bottom is the positive value, yes, and the y value on the top is the negative. And there's a specific reason for this. And the reason is that the top corner of your image here is your 0, 0. Usually in your traditional graph, this point over here would be your 0, 0. But in order to make it easier for your memory to read this image, save this image, it starts here because the computer reads this way easier if it reads each pixel in the order they have instead of starting here. If not, it will have to start with these pixels here in the center and then go up to the top and then go on the next pixel. So we are starting here as our 0, 0. Why I am telling you this? Because now we need to calculate directions. That means that we need to calculate this direction, this direction, this direction, yes, and this direction. And of course, bottom and top. Yeah, so we're gonna write this and this. And again, I'm mentioning this because usually when you talk about 0, 0, you would be referring to this value here to the center. But when you're talking about 0, 0, you're talking about the top left corner. So let's get back again to Designer and see how we can actually make this as a direction. So in here, we have our vectors. Now we need to give these vectors a direction. How do we do this? We multiply this by the value that direction has, as you can see. For example, if I go around here, yes, you're gonna see that we have a new direction. This direction is a -1, -1. But for this, I think I'm gonna bring my graph so you can visually see it at the same time and understand what I'm doing. So this here is my PureRef, again, here on Designer. I'm sorry for that short delay. Now let's get a look and see what are we assigning here. So first, we are multiplying our vectors by a -1, -1. That means that we are going in a negative direction. That means that I'm moving the first value, yes, of my float 2 is my x value, yes, this one. So I'll go in -1, and my second value is gonna be my y value, and it's gonna be a negative, so I'm going -1. This value is my top left corner, yeah. So I'm moving forward to the next one. In here, I'm doing 1, 1. I'm doing the opposites. The opposite to -1 and -1 is the bottom right corner. Yes, we're going 1 on x, 1 on y, and we are ending in this corner here. Yes, this corner here is 1, 1 in our float values. In here we have a multiplication by 1 per 0, so we are going 1 here, yes, and 0 on y. That means that we are holding here, this is the right. Yes, here we're working with my right direction. So I'm just, where did this comment go actually? So I want to hold a comment here and set this to be my right vector, let's call it. Yes, I'm gonna write this down actually. Just copy this one here. We're going for, this is not my right vector, this is my bottom right vector actually. So I'm gonna leave the right word and set this to bottom right. There we go. And this one should be the top left. Yeah, this way you can visually see it better. Now we keep moving now. Again, we have -1, 0. This is left. We are talking about here. Here is -1, 0. Yeah, and something I did wrong here that I'm gonna correct now is that I write the numbers together. Yeah, so when we're talking about float values, data types, we are usually write them like this: one number on top and the second number below. When we talk about these kind of things, these kind of values like pixel 0 and so on, we kind of write it like this, just to have a visual difference between one and each other. Like, it's kind of my rule. So we have -1, 0. Yes, this is left vector. Yes, I'm gonna come here and I'm gonna go to here and copy the left vector, left word here, so you don't have to type it. There we go. This is my left vector. And then we have 4 more. Yes, we have a 0, 1. 0, 1 means we are starting here and we're going here. Yes, so this point here, yes, is our 0, 1 float value or our bottom vector. Yeah, if I write it here, our bottom vector. Yeah, there we go. So now we have our top vector. Yes, our top vector, remember, is this one. This one is 0, -1. Yeah, numbers went really big out of the blue. So this is going to be top vector. And finally, we have these two. Yes, in this one, we have, again, directions. We have -1 and 1, that is bottom left corner vector, that is going to be to this one, sorry. And then we have the 1, -1, that means we go here, here, and it's top right corner. And bring this again and set this here. Now with all of this, we have our vectors. So how do we take these vectors? How do we use these vectors in here? So now I'm just gonna hide this for a moment, and we're gonna get back to this. So in here, what we created are the vectors of the directions. So I'm gonna frame this now here. Now you have your vectors in here, and you have all the directions. Yes, again, top left, bottom right, you have all of them. Now we need to apply this direction with the position of our pixel. So how are we doing this? So what we are doing is we are getting another getFloat2, and we are looking for the $pos function. The $pos function is basically the position of each pixel on our image. So that's what we are reading. And to this position, we're adding, yes, the vector. Everything you see here is basically we are telling our computer or substance designer to go from one pixel to the other one, from one pixel to the other one, from one pixel to the other one. Yeah, that's how we are doing it. Now that we have all of our vectors, we need to input this into some image, because right now here we are not reading any image. We're just telling them that to read the position of pixels and add this direction by 1. That means that we are moving our pixel by 1. If I were to do this by 2, it's going to take 2 pixels below. Sorry, 2 pixels farther. We're doing it by 1. Yes, so we are getting in here. We are adding this. So this is the original position of a pixel. If I were to go back to my PureRef here, yeah, and set this here, yes, the original position of my pixel will be this one. Then I'm adding a vector, so I'm going to another direction to read the next pixel, then the other one to read the another pixel, and that's how that's what's going on in this area. So we are adding the original position plus vectors. Yeah, so once we have this, we need to input this into a sample gray. Why? Because so far we are talking about what to do, but we are not telling the software where to do it. The sample gray allow us to tell where we want to take this. As you can see here, you have an image 0. If I were to go back here, yes, and add another clouds one with another disorder and set it into the input image 1 and then go back, this sample gray will have a second option that is the input image 1. Yeah, so we're not going to look into this one and we're going to move forward. Now, why am I adding the values of all my pixels just like that? Because as you have seen here, and we are dealing with a box blur, every cell has a value of 1. So if we multiply any number by 1, the result is going to be its same number. So instead of adding a multiplication in here, what we are doing is we are directly adding the value of all the pixels, yes, and in here we are dividing this by 9. And by doing that, what happens is that we get our blur. So far we created our box blur. As you can see here, our image has been blurred, but now we need to go for a Gaussian blur, and Gaussian blur works quite different. For our Gaussian blur, the kernel grid changed a lot. As you have seen before, I talked about the weights each pixel has in our kernel grid, and each pixel had a value of 1 because every single pixel in here is as important as the other one. But in our Gaussian blur, our most important pixel is the center one. We want to hold this pixel and we want to focus on the edges of our image, of the shapes of our images. So the first pixel, or the one we want to change, is going to have a value 4. This one, or the ones that are connected, the pixels that are connected to our main pixel, are going to have a value of 2, and those that are not connected or are not neighbors are going to have a value of 1. And what is going to change compared to with box blur? So usually in here, yes, in the box blur, if you have these values, so let me write them down here again. So if you have a 5, a 10, and an 8, plus an 11, plus a 2, plus a 13, 3, 15, and 20, usually what you have to do is to add all of these numbers together. With the Gaussian blur, yes, you have to do another math. Yes, with the Gaussian blur, this is gonna look something more like this. Yeah, it's gonna be 22, 22, 5, 28 here. Then we have 13 by 2, it's 26. Yes, 4 by 2, it's 8. Yeah, 1 by 3 is 3. 2 by 15 is 30, and 1 by 20 is 20. This would be the second grid that we have with the Gaussian. And if we add all of these together, the result is going to be different. So with this new Gaussian blur kernel, the result is 142, which is quite different to the initial value of 87 that we had before. And the division we have to do is as well different, as you can see here, that is marked on the scene. Why? Because we don't need to just count the amount of cells we have. We need to add the values, or we need to add the weight of each cell. And if we add them all together, it gives you 16. So we need to do this divided 16, and it's gonna give you the new value of our pixel that we need to replace here. But how do we do this in pixel processor? Once again, let's get over all of these things once, and let me show you some nice trick. So this is the node I just showed you, and we're gonna do something different. We're not just gonna get in here and just edit this. What we're gonna do is gonna be way different. We're gonna go back, and I'm gonna create a new pixel processor. And for this new Gaussian blur, what I'm gonna do is I'm gonna do this part, yes, this area. I'm gonna do it here in my output size. When you open Substance Designer and Substance Designer loads a node, it starts by calculating these outputs here, so the base parameters. It calculates each parameter one time, and that's it. So if we were to do this as we did it before inside the pixel processor, it will calculate this every single frame or second of our computer. So in order to avoid this, in our pixel processor node, you click on it and you go to your base parameter sections. Then you look for your output size and you click on the second icon and you create an empty function. Now in here, you can create the graph that you wanted to create before. And in order to do that, we need to do first a get float2 and look for the size of our pixel. Remember, we're going for the size of our pixel that is also going to give us the size of our image. It's going to tell us how many pixels do we have. Then we need to use a result float1 to choose which vectors we want to get. Yes, in this case, it's going to be x and y. And we need to divide this by 1. Yes, in both cases. Yeah, both values need to be divided by 1, and the 1 is a float value as well. Yeah, it's gonna have this as 1. Please enter. Yes, and this enter here. Now that we have this, we need to create a vector float2 that's gonna add all of them together. And now we have this. Now I'm not gonna go over again and write all of these here together once again. So what I'm gonna do to make it easier, I'm just gonna copy them, and first I'm gonna place them all here together to have one of these nodes, and I'm gonna copy this here. Go back here to my node, get in here, click on this so you can get inside again, click this here, and voila. Now you have your vectors. But how are we going to use them inside our graph? Because they are loaded here, but how can we use them? So first we need to declare variables, and in order to do that, we need to look for a set node. The set node is gonna take the information we're inputting of the data, and we can assign a name. So this is the top left vector, so I'm gonna do top underscore L underscore vector, and this is a way of naming convention, and I'm just gonna keep doing this. Drop this here. This is gonna be br vector, so gonna be br vector. This is the one that we already had. Yes, I'm gonna save this. Then I have here my right vector. In this one, I'm just gonna write right. There we go. We have left here. It's really important to have a really nice way of writing names and being really precise, because what's gonna happen is that then when you try to use them in your graph, you're not gonna remain your name, and you're gonna have to come back here and so on. So try keeping it simple for you. So for example, I know that this one is bottom left, because if I have bottom right, then this is bottom left vector. This is top. We have first top right. No. Top left vector, so this is top right. So I'm gonna write this as t underscore r vector. No, this is not that one, sorry. This is top. There we go. And this is bottom left vector. Yeah, there we go. And this is also not this. This is down. So 0, 1 was down. Sorry, that's my right. Bottom vector is down. Top vector is top. Bottom left vector, yes, is bottom left vector. And then here we have top right vector. So I want to check I didn't miss any of these. Top underscore r vector. And there we go. So we have top left, bottom right. There we go. Top right, bottom left. Then we have top, down, left, right. And that's it. Yes, we have all of them. Now, how are we taking these into our graph? So usually, if you take this into our graph, you have to get in here. You're gonna edit this, and you have to get a float too. The problem is that even if you call for this, let's say, you're not gonna find it here, because only Substance Designer shows the ones that have a $sign, the ones that are included in Substance Designer. So you have to write it. I'm gonna write top in here. And if I preview this, which I can't, the result is going to be 0. And the reason the result is going to be 0 is because we don't sequence this. We have to sequence this. We have to use a node called sequence node. Yeah, so I'm going to go here and set a sequence. The sequence node allows us to tell Substance Designer which part do we want to have compute first before the rest of them. So by adding these nodes, yes, I am telling it what Substance Designer should compute first before moving to the rest. So Substance Designer is going to start here, and when it gets to this point here, it's going to read that in the front, like more in the front, there's going to be a sequence. So he's going to start, okay, which is the first node of this sequence? It's this one, and it's the one on the in. So it's going to start here. So it's going to go here, then it's going to go here, and it's going to read these ones, and then to the next ones that are these ones, and so on. Now we are missing one extra thing, and we are going to miss a float 2. Sorry, a float 2, not a float value. And we're going to create another sequence, get all of these together, and set this, set this sequence as our output node, but we are not being able to do it. Not sure why. For some reason, Substance Designer is not allowing me to set a node as an output. Lucky, I have another graph where I already did this. So we're going to take a look into that graph as well. And I need to look for this one, and it's going to be this one. So you see that in here we have the vectors we created. Yes, we're getting a float. If you want to see how it looks, the part we were just doing, it looks exactly the same. Yeah, with the only difference that this node at the end, the sequence node, it's set as an output, but for some reason I can't set nodes as outputs. So I'm gonna go back to my graph. I'm gonna delete the previous one, and I'm gonna get into this node. Yeah, so this part is pretty much the same. I'm grabbing the position of all my pixels and I'm adding the vector. So I'm telling my computer to offset by 1 pixel in all directions. And I'm using that in, sorry, let's get this here. I'm using that in all of these. Yes, in all the images, the input 0, that means the image. So let's open PRS for a second, one last time. So as you can see, the pixels that are near our center pixel, yeah, have a different value to the one on the center or to in the corner. So we need to check that in order to make the following. So what we're gonna do is we're gonna see the pause is our center. So basically our main pixel, the pixel that we are calculating, we have to multiply it by 4. So we're gonna come here, we're gonna pull a multiplication node and a float value, and we're gonna do this, and we're gonna multiply this by 4. Yeah, I'm gonna apply this here. Yeah, and you're gonna see our image change. So then we have the rest: top, down, left, and right. Both of them are all by 2. So we're gonna get this here, multiply this first, get another float here, but this float is gonna be a 2. Yeah, so we're gonna start adding these things. There we go. This is down. And this is right. All of them by 2. Top, down, right, and I'm missing left. Left is really down on the bottom, so I'm gonna go here, pull this here, get another float, set this to 2. Yes, and we're almost there. So we have the ones that are connected multiplied by 2, the center by 4, and then we need to do the corners by 1. So I'm gonna get this in here. Yes, gonna get another float, and this float is gonna be multiplied by 1. Yeah, I'm gonna do this over and over. Yes, with all of the remaining images or pixels that we have. Yeah, and that should do it because we have all of these. But as you can see, we are not done. And we are not done because all of our image is just pure white. And the reason for that is because we need to divide by 16. So now the only thing we have to do, go back to our float value at the end for this dividing and set this to 16. Now our image is blurred and it has the right value. So I'm gonna save this and we're gonna go back. And now you have 2 nodes. One with a box blur and another one with a Gaussian. The difference is not that much, you can see it. In order to make it more important, we should add more things. How do we control the intensity of this? Usually to control the intensity of this, you need to increase the size of your kernel. That means that instead of doing a 3x3 kernel like we did here, yes, we would have to do a 6x6, 8x8 in order to do that. But it's not really good to do it or not recommendable to do it inside Pixel Processor. So what we are going to do in order to do that is we're gonna get the same type of blur, yes, in this case the box blur, and we're gonna copy this, paste it, and use it again. And this is going to allow us to blur our image from this to this, as you can see. If you have completed this video, then you should have 2 types of blur nodes, but this can be hard to be done alone. If you need help, you can join our free Discord community where professionals of the game art industry help and teach other students how to create the art we are creating in the biggest studios of the world. Now thanks for watching and let us know in the comments if you could understand everything in this video. Till next time.